In the last module, we looked at how firms determine their quantity of output and profit maximization in the short run for perfectly competitive industries. In this module, we're going to focus on how perfectly competitive firms in that type of industry determine long-run outcomes. We'll focus on the industry supply curve. We'll look at the difference between the short-run industry supply curve and the long-run industry supply curve. I'll explain why industry behavior differs in the short run and the long run, and discuss what determines the industry supply curve in both the short run and the long run. So as we continue our look at perfect competition, in the previous module, we showed how the marginal cost curve is the short-run supply curve for each perfectly competitive firm. We now expand that discussion to the entire industry that includes many such firms. The assumptions of perfect competition tell us that there are many small firms each producing an identical product. The implication of these assumptions is that each firm's cost curves are identical as well. In the last module, I showed you how at least above the shutdown point, the marginal cost curve is each firm's short-run supply curve. The firm will always observe the market price and then find the output level where price equals marginal revenue, which is equal to marginal cost. If the price rises, output rises along the marginal cost curve. If the price falls, output falls along the marginal cost curve. This table shows one firm that is producing at 4 different prices in the short run. And this is what that individual firm's cost curve would look like. You can see that the marginal cost curve crosses the average variable cost curve and the average total cost curve at the minimum of each of those points. And so any point above a price of $2 and a quantity of 3 will represent the firm's short-run industry supply curve, which will be its marginal cost curve. Now, if there are 1,000 identical firms that are responding in the same way to these 4 prices, the output supplied in the market as a whole is simply the summation of individual supply decisions, like that individual firm. You can see here that the quantity supplied in the market is just 1,000 times what was supplied by each individual firm at those prices. Now, because the shutdown price is at $2, there would be no quantity that would be supplied below that price. Each of these prices was determined by the intersection of market supply and demand, which is shown here. And so here is a review of the short-run individual firm's supply curve. Any point above point A, which represents the shutdown price at $10, along the firm's marginal cost curve will also be its short-run supply curve, because at any point above point A, the firm will supply a quantity that is equal to the price and the marginal cost at that particular price. So the marginal cost curve above point A is the firm's short-run individual supply curve. So now we look at the industry supply curve. Okay, that was an individual firm supply curve, but what about the industry as a whole, made up of all of those individual firms? The industry supply curve shows the relationship between the price of a good and the total output of the industry as a whole. So the short-run industry supply curve shows how the quantity supplied by an industry depends on the market price given a fixed number of producers. Because in the short run, the number of producers will not change. In the long run, the number of producers in the market can change and produce a different quantity of output. So there is a short-run market equilibrium when the quantity supplied equals the quantity demanded, taking the number of producers as a given. So when we do that, we derive a short-run industry supply curve that looks like this, where the market price determined is $18 and a quantity of 500 tomatoes will be supplied in the market as a whole by all of those individual firms. Now, if we draw side-by-side graphs for a perfectly competitive industry and firm, ask yourself, well, is the firm represented here making a profit or a loss? Well, first, we draw the industry supply curve in a perfectly competitive market on the left. It faces a downward sloping demand curve, an upward sloping supply curve, and the market price would be determined to be $15, and 5,000 units would be produced by the industry as a whole. So for the individual firm, shown on the right, it has to accept that market price of $15 as a given. But its demand curve for the individual firm would be perfectly elastic at that price and would represent marginal revenue and the demand curve of the firm. That individual firm would then look at its marginal cost curve and determine that marginal cost equals marginal revenue at a quantity of 8, and because the firm's minimum of average total cost is below that price, the firm is making an economic profit. Now, let's look at this. Which of the following is a correctly labeled graph for a firm making economic profit? Is it graph number 1, number 2, number 3, or number 4? You may wish to pause the video to examine these graphs and determine which one you think is correctly labeled. The answer to that question is that they are all wrong, but for different reasons. Okay. Graph number 1 is wrong because it shows an economic loss, because the minimum of average total cost is above the price. Graph number 2 is incorrect because it's showing marginal revenue equal to demand and ATC and MC drawn correctly, but the quantity of output is not where marginal revenue equals marginal cost. Graph 3 is wrong because profit is too big. The shaded area in green should be smaller. It should be bumped up to the point where average total cost curve comes in. So the profit's too big. And in the fourth one, okay, marginal cost and average total cost are labeled incorrectly. What is shown as average total cost is the marginal cost curve, and what's shown as the marginal cost curve is the average total cost curve. So they're all wrong. Now, in this graph, where is the profit maximization point? Well, it's where MR equals MC. And those curves intersect at a price of $20 and a quantity of 10. Now, that's the output that we should produce. So what is the total revenue? Well, the total revenue is the price multiplied by the quantity. So you take a price of $20, multiply it by 10, and that's $200. What is the total cost? Well, the total cost of producing this good would be, you draw a line down from where marginal revenue equals marginal cost to the average total cost curve, and that is the average total cost of producing that good. That is $15. You multiply that times the quantity, and that means the total cost of producing it is $150, the area shaded in yellow. So, how much is the profit or loss? Well, you take the price, $20, minus the average total cost of 15, that's the profit per unit, $5 per unit, and you're producing 10 units, so you multiply 5 times 10, and that's 50. So there is $50 of profit being made. What is the shutdown point? It's any price below the minimum of average variable cost. Well, how do you know where the minimum of average variable cost is? Well, it's circled here. It's where the marginal cost curve intersects the average variable cost curve at its minimum point. So that looks like it's maybe a price of around $12 or so on this graph, and that would be the shutdown point for the firm in the short run. Here's an activity on profit maximization and loss minimization that we will do in class. So now let's look at perfect competition in the long run. Let's assume you are a wheat farmer and you learn there is more profit in making corn. What do you do in the long run if you're growing wheat? Well, in the long run, if you see there's more profit making corn, you'll want to switch to making corn. So firms will enter the industry if they see there are economic profits being made. Firms will leave the industry if there are economic losses being made. This is what they can do in the long run because all inputs are variable in the long run. So in the long run, all firms break even. They make no economic profit, nor do they make an economic loss. They make a normal profit in the long run under perfect competition. So in long run equilibrium, a perfectly competitive firm is extremely efficient. And that's one of the important points to know about a perfectly competitive industry and firm. It is the most efficient of all four types of market structures. Here's a side-by-side graph for a perfectly competitive industry and firm in the long run. Is the firm making a profit or a loss? It's making neither. Because notice that the minimum of average total cost is where marginal revenue and marginal cost are equal to each other. So the firm is neither making an economic loss because the minimum of ATC is not above the price, nor is it making an economic profit because the minimum of ATC is not below the price. It's exactly equal to the price. So it's making a normal profit in the long run. So a firm in long run equilibrium looks like this. The price will be equal to the marginal cost, which will be equal to the minimum of average total cost. The firm is making no economic profit, but the firm will be making positive accounting profit. So when there are no losses or no profits, there's no incentive for other firms to enter the industry to make profit because no economic profit is being made, nor are there any incentives for firms to leave the industry because they're producing just enough to cover all their costs. And so they're not making an economic loss and don't want to leave the industry. So how do we go from the short run to the long run? A market is in long-run market equilibrium when the quantity supplied equals the quantity demanded, given that enough time has elapsed for entry into and exit from the industry to occur. So, is this the short run or the long run? And why? Well, this would be the short run, because from this graph you can see that a firm is making economic profits. And it will only make profits or losses in the short run. In the long run, firms earn no economic profits or losses, and so they are only earning a normal profit. So what will firms do in the long run here? Well, because economic profit is being made, firms will enter the industry. And what will happen to the price and quantity in the industry? Well, as firms enter the industry, profits will continue to go down as a result of that. And so in the industry, the price will stay the same and the quantity, let's see. Firms will enter to earn profit. So what does that do to the supply curve? It shifts the supply curve to the right because there are more producers. So the supply will increase. Well, now we have a new equilibrium price. The equilibrium price goes down to $10. And the quantity produced by the industry increases to 6,000. But notice what happens to the individual firm. The individual firm will be producing 8 units, even though more units are produced in the industry as a whole because of new producers. Here's another graph that shows you the same thing happening. That when new producers come into the industry, because they're attracted by economic profits, it will shift the supply curve to the right, and the market price will drop, and the output in the industry, represented by those new producers, will increase. So this process is referred to as long-run adjustment. Why? Well, why won't profits last in the long run? Well, first of all, profits exist in the short run. And then the market sees entry of new firms attracted to those profits. More producers in the market shift the short-run market supply curve to the right. The price begins to fall in the market, and as the price falls, each firm produces less quantity along the marginal cost curve. So individual firms, even though the market as a whole will be producing a larger output, each individual firm will produce a smaller quantity as it moves further down its marginal cost curve. And so profits for each individual firm will fall. And then as the price continues to fall, eventually it will reach the break-even point at the minimum of average total cost. When that happens, then entry into the industry by other firms will stop. Now, as you've seen in prior graphs, if I go back to a previous one, the graphs for the market and the firm are usually drawn side by side to see how they are interconnected. Now, you should be familiar with this because you may have to draw it on the AP exam. Now, as the short-run market supply shifts to the right, you can see the price falls in the market. The firm responds by moving downward along the marginal cost curve. And the last firm enters when the price drops to $6, and only normal profits are possible when price is equal to average total cost. So while each firm produces less, there is more total output produced in the market because more firms now exist in the market. This is referred to as long-run equilibrium in the perfectly competitive market and for the firm. Here is where you see the firm moving down its marginal cost curve and producing less output on its own as the price falls from $8 to $6. So for the individual firm in the long run, their quantity of output will go down, but the total output in the industry will increase. So as the market adjusts from long-run to short-run equilibrium and back to long-run equilibrium, we can trace out the long-run market supply curve shown here. The market is in long-run equilibrium at a price of $6 and a quantity of 10,000 units at point A. Each firm is earning a normal profit and producing 7 units of output. Suddenly, market demand rises for this product to D1, and the demand curve shifts out to the right. Now the new equilibrium is at point B. It's at a higher price, a price of $8, and the quantity of output has increased to 11,000. Firms are now earning positive economic profits in the short run. Because of that, new firms are attracted to the industry and they enter the industry, and that causes the short-run supply curve now to shift outward to the right to S1. And so the new equilibrium point becomes point C. The price has now returned to $6. Firms are now earning normal profits again, and long-run equilibrium is restored at point C. If we connect the points that reflect long-run equilibria, we can trace out the long-run market supply curve from A to C, and it's labeled as LRS, and it's horizontal between A and C. Now, why is the long-run supply curve horizontal, and does this make sense? Well, by drawing it this way, we are assuming a constant cost industry. This means that the entry of new firms does not affect the input costs in the industry. So here's what that long-run market equilibrium looks like. Notice that at an original price of $18, looking at the graph on the left, the market equilibrium is $18. So for the individual firm, they will be producing at point E a quantity of 5 tomatoes at a price of $18, the market price. In the market as a whole, that means 500 tomatoes will be produced. But notice the firm is making economic profit because where marginal revenue of $18 crosses marginal cost, you go down to the average total cost curve at point Z, and you can see that the firm is making economic profits. $18 minus $14.40 per unit multiplied by a quantity of 5, and so it's the area shaded as A, that green area. But those profits will attract new suppliers to the industry. And so the supply curve in the market, panel A, shifts to the right, and the price falls to $16. For the individual firm, it will move down its marginal cost curve from point E to point D, and at a price of $16, it will produce a smaller quantity of only 4.5 tomatoes, even though more tomatoes are being produced in the market as a whole, 750 now, represented by those new firms producing. But it's still making economic profits, but its economic profits have now fallen to the area shaded as B. The point from point D to point Y is now the individual price per unit, a quantity of 4.5 tomatoes. So because it's still making economic profits, more firms will still be attracted to the industry. And so it will continue to shift the supply curve to the right until we reach a price of $14, which, notice, is the break-even price. So at that point, the quantity produced by the industry increases to 1,000 tomatoes, but for the individual firm, its quantity of output is reduced from point D to point C from 4.5 tomatoes, now producing only 4 tomatoes. And it is no longer making any economic profit. It is making a normal profit because it's at the break-even price. And that is where entry into the industry will stop, at a price of $14, making normal profits. Now, here's a tip for the AP exam. You may wish to draw dotted lines taking the equilibrium price from the market graph over to the individual firm graph to show your understanding that the firm is a price taker, especially if you're asked to draw side-by-side graphs representing the industry and the individual firm in a perfectly competitive market. So the price falls for the firm because they are price takers. So the price decreases and the quantity produced by the individual firm decreases, in this graph from 8 to 5, even though the overall industry output increases from 5,000 to 6,000, represented by new producers. So this allows us to reach a new long-run equilibrium at a price of $10, with zero economic profit being made by individual firms and no more firms entering the industry. Now, in this graph here, is this the short run or the long run? Well, this has to be the short run, because here we see economic losses are being made by the individual firm because the price is below the minimum of average total cost. And that's how we know that. So what will firms do in the long run? Well, they'll leave the industry because losses are being made. Firms will leave the industry. So what happens to price and quantity in the industry, and what happens to price and quantity in the individual firm? Let's take a look at that. Firms are going to leave the industry to avoid losses, so supply will decrease in the industry, shifting the supply curve to the left. That means there will be a higher price of $20 and reduced output in the industry, going from 5,000 to 4,000. For the individual firm, now they will be getting a higher price for their firm of $20, and so with that higher price, the price now comes up to the minimum of average total cost. And so for the individual firm, they will actually increase their quantity of output from 8 to 9, even though it's reduced in the industry as a whole, and the firm in the long run will be making a normal profit. So we have reached a new long-run equilibrium at a price of $20 with zero economic profit. So whether economic profits are being made in the short run or economic losses are being made in the short run, they will cause firms to enter the industry or exit the industry until there are zero economic profits being made by the individual firm, and that is the long-run equilibrium for the market and for the individual firm in a perfectly competitive industry. So this is going from the long run to the long run in a constant cost industry. New firms entering the market does not increase the costs for the firms already in the market. So here we're currently in long-run equilibrium. But what if demand increases? What happens in the short run, and how does it return to the long run? Well, if demand increases, it shifts the demand curve to the right. So in the market, the price rises from $15 to $20, and the quantity is going to increase as well. Well, when the price rises, now the firm is in a short-run equilibrium because the price is above the minimum of average total cost. And so the firm in the short run is now making economic profits. So because of that, firms are going to enter the industry to make some of those profits, so supply in the industry will increase and shift to the right. But when it does that, the new equilibrium is at S1 and D1, so the price will fall from $20 to $15, and when that happens, that price is now at the minimum of that individual firm's average total cost. And so the firm will reduce its output from 9 to 8, and once again, it will be making a normal economic profit in the long run. Now, back to long run equilibrium. The only thing that has changed from long run to long run, when we go from the long run into the short run, then back to the long run, is the quantity in the industry. That's the only thing that changes when we go from long run to long run. For the individual firm, they are earning a normal economic profit in the long run, and when we go to the long run, they're still earning a normal economic profit. But the change that has taken place in the industry is that the quantity produced in the industry as a whole has now increased. What if demand falls? If demand decreases, what happens in the short run? How does it return to the long run? Well, if demand decreases, and shifts from D to D1, the price is going to fall from $15 to $10. And as that happens, well, that means profit is going to be made by the individual firm in the short run. But the price will increase and the quantity will increase. So profit is made in the short run. So this shows you the effect of an increase in demand in the short run and the long run for a constant cost industry. You can see in panel A, the existing firm's response to an increase in demand is to increase its output from X to Y, making economic profits. That causes the supply to increase by attracting new entrants into the market. So in panel B, the supply curve shifts from S1 to S2. So for the individual firm, so that means the quantity in the market increases from QY to QZ. But notice for the individual firm, the price falls back to $14 and it goes from point Y to point Z, and so it drives the price and profit back down to a normal profit. So the overall quantity in the market has increased in the long run, but for the individual firm, they're back to a normal profit. They only have economic profits in the short run. So approach changes that have long-run repercussions one small step at a time. First, show the initial change on your graph. Then, analyze the short-run effects of that change. Finally, focus on the adjustments that lead to long-run equilibrium. Here is a video that you can watch entitled Creating Long-Run Supply in a Perfectly Competitive Constant Cost Industry.
That we did in class today in order that you can look at them animated and hopefully they make some sense. So let's get started. I'm going to draw my axes here, label them price and quantity. Right, and we are looking at a constant cost industry, and we're going to begin in long-run equilibrium, so I'm drawing my supply and demand curves. These are our initial supply and demand curves. I'm going to label them S0 and D0. And they correspond to a quantity of Q0 and a price of P0. Now, the question says that demand increases, so I'm going to shift demand out to the right. That happens, I'm going to call that curve D1 because it happens after the D0. Now, we started in a long-run equilibrium at P0 and Q0, so that means that at that point, firms are making zero economic profit. Now we move to a short-run equilibrium point right here at Q1 and P1, which correspond to the curve D1. Now when the price goes up, firms make profits. Other firms see those profits and they are attracted to that industry. So new firms enter the industry, and in the long run, we give them time to enter the industry. That's going to shift the supply curve to the right, and that's going to make a new supply curve right there. Actually, let me redraw that. Nope, sorry. We'll call that S2 because it happens after D1. So now this new long-run equilibrium point is associated with Q2, and because it's a constant cost industry, production has expanded and P2 is equal to P0. If we want to make our long-run supply curve, we just take this first long-run equilibrium point and the second long-run equilibrium point, we connect them, and that is our long-run supply curve. Notice that it is flat, it is perfectly elastic. The long-run supply curve is more elastic than the short-run supply curves. Right, so that is what a constant cost industry looks like, and I will make another video for an increasing cost industry.
And we will do some practice with a constant cost industry in class. Here are some practice questions that you can pause the video for. I'll run through them quickly, but if you want to stop and pause the video on each of these questions to review them, these are questions that appeared on past AP exams, so you can check your understanding with these. Here is the rubric for the free response question that you just saw in the previous slide. So now, what if we go from the long run to the long run in an increasing cost industry? We just looked at a constant cost industry. That would be new firms entering the market, and it would increase the costs for the firms already in the market because maybe an input is in short supply, and by purchasing it, it raises the price of that input. This has only been asked once on an FRQ in 2011 on Form B, so it's not common, but you should be familiar with it. Okay? So, in an increasing in cost industry, entry of new firms increases the input costs for all firms. Suppose the market drawn here was for an agricultural product like melons. How would the entry of new firms affect input costs? Well, new melon producers will need land as a key input, and there's only so much land available. As the demand for land increases, the price of land is going to increase, thus an increasing cost industry. The result is that the market price will not revert to the original long-run price of $6. It will eventually settle somewhere between the short-run price of $8 and $6. In other words, the long-run supply curve for an increasing cost industry will be upward sloping. So if demand increases, what happens in the short run? How does it return to the long run. In an increasing cost industry, the price increases and quantity increases. So when that happens, profits are made in the short run, and you see that represented here. Firms enter to earn profit, but the fight for resources causes costs to increase. And so the price falls, but not back to the original price of $15. It may fall back to $20. And notice, because costs have increased, you have to move the individual firm's ATC curve up to ATC1, representing its increased costs, and its marginal cost curve moves up from MC to MC1, representing its increased costs. And so the minimum of ATC and the point where marginal revenue equals marginal cost will be at different points now, and so it will earn a normal profit, not at the original price of $15, but somewhere in between that price of $15 and $25. And on this graph, that looks like a price of $20 in an increasing cost industry. So it looks different because of that. So firms enter to earn profit, but the fight for resources causes the cost to increase, and so the price falls to $20. Here's a question from a prior AP exam dealing with a constant cost industry. Here you see a graph that shows the effect of an increase in demand in the short run and long run for an increasing cost industry. Notice in panel C how the average total cost curve is shifted upward, the marginal cost curve is shifted upward, and that creates a new normal profit for the firm. So the price, even though it temporarily increases from $30 in short run equilibrium or in long run equilibrium to $42 in short run equilibrium, profits are being made, but because the costs go up, the price eventually settles back, but at a price somewhere between 42 and 30, representing those increased costs, which now determine the point at which a normal profit is being made. And that will now be at point Z rather than point X for the individual firm, at a higher price now of $35 in long-run equilibrium. Here's an activity that we'll do on increasing cost industry in class. The other thing that can happen is it's also possible for a market to have a downward sloping long-run supply curve. When it's an increasing cost industry, you have an upward sloping long-run supply curve that is more elastic than the short-run industry supply curve, but not perfectly elastic like under a constant cost industry. But if you have a decreasing cost industry, the long-run supply curve will actually be downward sloping. This is when a market, this would occur if entry of new firms actually caused inputs to become less costly, and there might be economies of scale. In your textbook, it provides the market for electric cars as potentially a good example. As more firms produce the cars, the infant industry of lithium batteries explodes, and average costs due to economies of scale fall as more batteries are produced. And so you can see the impact on the individual firm in panel C. Instead of the average total cost curve and marginal cost curve shifting up as they did in an increasing cost industry, now they shift down in a decreasing cost industry, and so the price eventually falls to where price equals the new marginal cost at a different point. Instead of that being point X, as it was originally, it will now be point Z. So the price will settle back down below the original price of $40,000 to maybe somewhere around $30,000. And you can see in panel B the effect that has on the long-run supply curve, leading it to be downward sloping. So when we compare the short-run and long-run industry supply curves, the short run industry supply curve will always be much steeper and much more inelastic than the long run industry supply curve. The long run industry supply curve will be much more elastic. If it's a constant cost industry, it will be perfectly elastic, but even if it's an increasing cost industry, it will only be somewhat elastic. So the long run industry supply curve is always flatter and more elastic than the short run industry supply curve. So recall we are going to use perfect competition as a benchmark for looking at all other market structures. We will measure other market structures against the long-run outcome on these three criteria that are true for firms and the perfectly competitive industry. Number one, in a perfectly competitive industry, marginal cost is the same for all producers because price is the same for all producers. Secondly, economic profit is equal to zero for all producers. All firms earn a normal profit in the long run. Because this can only happen at the minimum of ATC, we can say that firms produce this product at the lowest possible average cost. This represents productive efficiency since price is equal to the minimum of average total cost. So two things are true. Because of the first point, because marginal cost is the same for all producers, because price is the same, that means the good will be sold for a price that equals marginal cost, and the price people pay is their marginal benefit, the value they place on it. So the value society places on something will be equal to the price, which will be equal to marginal cost. So under long-run equilibrium, we reach allocative efficiency, and because of the second point, because they're producing where price equals minimum of ATC, we reach productive efficiency. So because we have both allocative efficiency and productive efficiency with perfect competition, the market is efficient under perfect competition, and it's the most efficient type of market that exists. And you'll see this when we compare it with the other three types of market structures. So the third point is that the market is efficient. All consumers who are willing to pay the price that is greater than or equal to the seller's marginal cost will get to buy the good. In other words, there is no deadweight loss in perfect competition because all mutually beneficial transactions are made. Every buyer can find a seller, every seller can find a buyer. And this represents allocative efficiency since price is equal to the marginal cost. We'll do this activity in class on market and firm relationships. And so this reminds you of the characteristics of perfect competition. So in general, efficiency is the optimal use of society's scarce resources. Perfect competition forces producers to use limited resources to their fullest. Inefficient firms have higher costs and are the first to leave the industry. Perfectly competitive industries are extremely efficient, both productively efficient and allocatively efficient. They're productively efficient because they're producing at the lowest possible cost, where price is equal to average total cost. That means the minimum amount of resources are being used to produce the good. So graphically, this is where price is equal to the minimum of average total cost, and that's a long-run equilibrium. They're allocatively efficient because they produce at the amount most desired by society, by allocating scarce resources towards the products that society wants. Graphically, that is shown by producing where price equals marginal cost, and that is true in the long run as well, under perfect competition. So notice that in the short run, where profits are being made, that at Q1, it's not being made at the lowest possible cost, because average total cost is not at its lowest point. So in the short run, it's not being efficient. So there's no productive efficiency in the short run under perfect competition. Notice that quantity 2 is not being made at the lowest possible cost because ATC is not at its lowest point. But in the long run, quantity 2 is being made at the lowest possible cost, where ATC is at its lowest point, so in the long run, under perfect competition, we achieve productive efficiency. We are also achieving allocative efficiency, but notice in the short run, the price people are willing to pay equals the additional cost to produce quantity 1, where price is equal to marginal cost, even when we're making short-run profits. But notice we're not being allocatively efficient here at quantity 2. The price is now greater than the marginal cost, so society wants more output produced. In long-run equilibrium, a perfectly competitive profit-maximizing firm is always allocatively efficient as well. Here's an activity that we'll do in class. And so the summary of this is that perfectly competitive firms are allocatively and productively efficient in the long run. In the short run, they are always allocatively efficient, but they are not productively efficient. They are always allocatively efficient, but they are not productively efficient in the short run. Here's a video that you can watch on AC/DC Econ by Mr. Clifford, Perfect Competition in the Long Run. Here's an activity that we will do in class. Here's a description that will give you an example of grape production in the wine industry and how it adjusted in the long run. If you want to pause the video and read this, I'll give you time to do that. I want to wrap this up because I know this has gone kind of long with this module. Here's another activity we'll do in class on perfectly competitive markets. Here's an AC/DC Econ video on graphing perfect competition practice from Mr. Clifford. Here's another activity on long-run equilibrium and efficiency we'll do in class. And then here is the summary slide of what we learned in Module 60 on the long-run outcomes in perfect competition. This concludes our look at Module 60, Long-Run Outcomes in Perfect Competition.